Hi students, success. Today in this video I am going to start one more new topic, that is normal form. Okay, I will explain the concept of Anand. Hi students, welcome to Sankalp Study Success. Today in this video I am going to start a new topic, that is normal form. This normal form is also called as canonical form. Today in this video I will explain you the definition of normal form and its working rule. Based on that, I am going to make you to solve few problems. Let's start the class. Hi students, welcome to Sankalp Study Success. Today in this video, I am going to discuss another important topic, how to find the rank of a matrix using normal form. Okay, first let's see the definition of a normal form. This normal form we can also call it as canonical form. Okay, first let's see the definition, then I will explain you clearly. Every m by n matrix of rank R can be reduced to the form IR000 by using a finite number of elementary row or column operations, where IR is a unit matrix. Then the above form we call it as normal form or canonical form of a matrix. What does actually meant by this is, we have to first reduce whatever the matrix that is given into identity matrix. In order to reduce that into identity matrix, we should make use of both row and column operations accordingly, depending upon the problem. So, okay, once the matrix has been reduced into identity matrix, the suffix R decides the rank of the matrix. I will explain you this with an example, students. See here. For example, okay, after solving the problem, the matrix has been reduced to 1 0 0 0 1 0 0 0 0. Okay, this is how the matrix has been reduced. Let us assume. Okay, now if you observe carefully, this 1001 is a 2 by 2 identity matrix. So how can I write this 2 by 2 identity matrix? Simply I can write it as I2, because it is a 2 by 2 identity matrix. And what are the zeros that are left here? 1 2 3 4 5. Okay, 5 zeros are left. So instead of writing all those 5 zeros, if I simply write like this, see 0 0 0, this is enough. Okay, so this is what we got it as the final matrix I2 0 0 0. Now what is the suffix here? 2 is the suffix here. So now what will be the rank of the matrix? Whatever the suffix is there, that becomes the rank of the matrix, that is 2. Or you can make use of the concept called like the rank of the matrix is nothing but the number of non-zero rows. Okay, so how many number of non-zero rows are there? This is non-zero row and this is a non-zero row. 2 non-zero rows are there. So even in that case also the rank is equal to 2. So you can make use of either of the concepts in order to find the rank of the matrix. Is that clear, students? Now let's see the most important topic. What are the steps to find the rank of the matrix using normal form? These steps are very important while solving the problems, and you have to follow the same order what I am going to explain now. So this is a 3 by 3 matrix. As you can see, this is a 3 by 3 matrix, and whatever the concept I am explaining now, this concept will be applicable for any order of the matrix. Let it be a 4 by 4, 3 by 2, 2 by 3 or 3 by 4. Let the order be anything. The same concept will be applied to all those order of the matrices. Okay. First, step 1. What is step 1? We have to make A11 is equal to 1. This is step 1. Step 1 is make it 1. That is, make A11 1. For that we have to find the possibilities for swapping with any other row or column which has got 1 as the first element. Next, immediately after that we have to make the elements below A11 0. That is A21 and A31. Okay, this is step 2. Make it 0. Okay, so this is step 2. Make it 0 using R1. We have to make use of first row in order to make these two elements 0. Okay, now step 3 is make A12 and A13 0. Okay, step 3, we have to make these two elements 0, making use of column 1. Okay, I am writing here. This is step 3. Make it 0 using column 1. Okay. Now, next come back to the second diagonal element, that is A22. We have to make this A22 1. That is step 4. That is step 4. Make it 1. Now next we have to make the element below this second diagonal element, that is A32, as 0. For that you have to make use of step 5. Make it 0 using R2. Okay. Now next, the next element that we have to make this A23 0 by making use of column 2. Okay. Make it 0. This is step 6. Make it 0 using column 2. Next, the last element, that is last diagonal element, A33, make it 1. That is step 7. Totally we have 7 steps to be performed. Remember this order. Okay, make it 1. Is that clear, students? So, and one more point we have to make a note of it is, the last row of any order of the matrix can be made 0. It is not compulsory that the last diagonal element should be 1. No, there is no compulsion. This complete row can be made 0. For example, if I take a 4 by 4 matrix, 1 0 0 0 0 1 0 0 0 0 1 0, and last one is 0 0 0 1. Actually this should be a 4 by 4 identity matrix, right? But it is not compulsory while solving the problems or while reducing the problems. It is not compulsory that this element should be 1. Okay, you can make this element 0. You can make this element 0 so that the last row can be made 0. And now what are the elements that are left here? See, 1 0 0 0 1 0 0 0 1. How does it look? It looks like a 3 by 3 identity matrix. So the rank of the matrix in this case will be equal to 3. Or what are the number of non-zero rows? 1 2 3. Even in this case also the rank is equal to 3. Is that clear, students? Now, and one more point here, before performing step 3, if you feel that you can make any other row operations or column operations so that the problem can be made very easily, then you can perform before step 3 those row and column operations and go for step 3. Is that clear, students? Now coming to the problems. Reduce the following matrix into normal form and then find the rank. This has been asked in 2006 and 2007. Okay, first let's consider this as A is equal to 0 1 2 minus 2 4 0 2 6 2 1 3 1. So this is our given matrix. Now we have to reduce this matrix into identity matrix, then we have to find the rank of the matrix. Okay, what is the first step? I already explained in the previous slide. I have to make this element 1, but it is 0 here, so I have to check for the possibility for swapping with any row or column. Luckily, see the column 2, the first element of column 2 is 1. So I can swap column 1 and column 2. Okay, so this is R1, R2, R3. This is C1, C2, C3 and C4. So I am swapping C1 and C2. So how does the matrix look like? That is interchanging the columns. So the first column is now 1 0 1, the second column is 0 4 2, third column remains the same, and also fourth column remains the same. Clear, students? So this is how the matrix looks after the swapping operation. Now immediately, what is the second step? I should make these two elements 0. Okay, already this element is 0, so no need to perform any operation for this element. We have to check for this element. So if I subtract R3 from R1, I can make this element 0. Okay, so what is the operation here? R3 implies R3 minus R1. So A is equal to, so R3 minus R1, I will do it here, students. R3 minus R1. So what is the first element of R3? It is 1 minus 1 is equal to 0. 2 minus 0 is equal to 2. What is the third element of R3? 3 minus 2 is equal to 1. And 1 minus of minus 2 is equal to 1 plus 2, that is 3. So now we will replace the third row with the new elements. The first row and second row remains the same. 1 0 2 minus 2 0 4 2 6 0 2 1 3. This is the matrix that is obtained after this row operation. Now immediately I have to go for step 3. But before step 3, if I divide the second row by 2, then second row and third row will become same. So I will do that operation before step 3. Okay, so that is R2 implies R2 by 2. So now what does, sorry students, here we have to make use of this symbol, not equal to symbol, not equal to symbol. I have to make use equivalent, like equivalent. Okay, this equivalent. Now the first row remains the same, that is 1 0 2 minus 2, and I am dividing the second row by 2. 0 4 by 2 is 2, 2 by 2 is 1, 6 by 2 is 3. And what is the third row? 0 2 1 and 3. See here, now the second row and third row are same. Now I can subtract these two so that the third row will be made 0 completely, and the problem will be made easy. Okay, so R3 implies R3 minus R2. Okay, so now how does this look like now? It is imply this equivalent to, there will be change in R3 only. R2 and R1 remains the same. 1 0 2 minus 2 0 2 1 3. R3 minus R2. See here, 0 minus 0, which is nothing but 0. 2 minus 2 0. 1 minus 1 0, and last one is 3 minus 3 0. So 0 0 0 0. Is that clear, students? Next, now I have to go for step 3, that is I should make these elements 0. Okay, this element is already 0, so no need to perform any operation. I have to make these two elements 0 now. For that I should make use of column 1. See, if I multiply column 1 with 2 and subtract from column 3, then I can make this as 0. Okay, so I will write the operation here. Column 3 implies column 3 minus 2C1. In the same way, coming to C4 implies, this is a negative number, so I should add with C1, that is C4 plus 2C1. Okay, I'll perform here, students. C3 minus 2C1 first. What is the first element of C3? It is 2. 2 minus 2 into first element of C1 is 1. So it is 0. Now what is the second element of C2? It is 1 minus 2 into 0. It's nothing but 1. Next last element is 0 minus 0, which is 0. Next I will take the C4 plus 2C1. What is the first element of column 4? It is minus 2 plus 2 into C1 is 1. 2, minus 2 plus 2, it is 0. What is the second element of column 4? It is 3. 3 plus 2 into 0 is nothing but 3. And what is the third element of column 3? It is 0 and plus 2 into it is 0. Now we will replace this column 3 and column 4 with the new elements that we got here. So it is equivalent to the first column remains the same 1 0 0 0 2 0, okay, 0 1 0, and here it is 0 3 0. Is that clear, students? Now after making these as 0, I should come back to the second diagonal element. What is the second diagonal element? It is 2 here, but I should make that second diagonal element as 1. So I will swap this C2 and C3 so that this element becomes 1. Okay, clear, students? So swap C2 and C3. So what you'll get here, the first column remains the same. The second column now it is 0 1 0. The third column is 0 2 0, and the fourth column is 0 3 0. Yes. Now after this element has been made 1, okay, the element below this is already 0, so there is no need to perform any operation here. Next I have to go back to here. I have to make these two 0. For that I will perform the operation like C3 minus C3 implies C3 minus 2C2 and C4 implies C4 minus 3C2. Clear, students? After performing this, if you want, I will do it here. C3 minus 2C2. What is the first element of C3? It is 0 minus 2 into 0, which is nothing but 0. What is the second element of C3? It is 2 minus 2 into 1. 2 minus 2 is 0. What is the third element of C3? It is 0 minus 2 into 0, which is nothing but 0. Now what is the second operation, column operation? C4 implies C4 minus 3C2. What is the first element of C4? It is 0 minus 3 into first element of C2 is 0. So it becomes 0. Now what is the second element of C4? It is 3 minus 3 into 1. 3 minus 3 is 0. And the last one is 0 minus 3 into 0, which is nothing but 0. Now we will replace C3 and C4 with the new elements that are obtained here. So first column will remain the same 1 0 0. Okay, second column also remains the same. Now what are the elements of C3? Now we got 0 0 0, and C4 we got it as 0 0 0. Just if you observe carefully, see here, it is a 2 by 2 identity matrix and all are made 0. This is 2 by 2 matrix. So how will you write this now? This implies 2 by 2 identity matrix, right? I2, instead of writing the remaining all zeros, Simply write it as 0, 0, 0. So now what is the rank of the matrix? Rank of the matrix is equal to 2 because the suffix is 2. Or you can also check for the number of non-zero rows. Number of non-zero row is R1 and R2. So 2 non-zeros. The rank is 2. Hope it is clear for you students. Now let's go to the second problem. Find the rank of the following matrix using normal form. This has been given in 2011 question paper. So this is the matrix. I will rewrite this matrix once again clearly. So A is equal to 1, 2, minus 2, 3, 2, 5, minus 4, 6, minus 1, minus 3, 2, minus 2, and last row is 2, 4, minus 1 and 6. Just a second children, I'll just check out whether the question is right or wrong. Give me a minute. Yes, the question is correct now. Okay, so let's start the steps here. The first element is already 1, so there is no need for swapping. Now I have to make all these 3 elements 0. For that I have to make use of first row. So what are the operations here? R2 implies R2 minus 2R1. This is one operation. And coming to the third, R3 implies third element is a negative number, so we have to add R3 plus R1. And coming to R4, R4 implies R4 minus 2R1. Okay students, I will do this here. Rough work. First is R2 implies R2 minus 2R1. What is the first element of R2? It is 2 minus 2 into first element of R1 is 1. So 2 minus 2 is 0. What is the second element of R2? It is 5 minus 2 into 2. 5 minus 4 is 1. Next, what is the third element of R2? It is minus 4 minus 2 into minus 2. Minus 4 plus 4, it is 0. What is the fourth element of R2? It is 6 minus 2 into what is the fourth element of R1? It is 3. So again 6 minus 6 is 0. Now what is the second operation? R3 implies R3 plus R1. What is the first element of R1? Minus 1 plus first element of R1 is 1. It is 0. What is the second element of R3? It is minus 3 plus 2. It is nothing but minus 1. What is the third element of R3? It is 2 plus R1 element is minus 2. So 2 minus 2 is 0. What is the fourth element of R3? It is minus 2 plus 3, which is nothing but 1. Next, what is the third operation we have taken here? R4 implies R4 minus 2R1. What is the first element of R4? 2 minus 2 into first element of R1 is 1. So 2 minus 2 0. Okay. Now what is the second element of R4? It is 4 minus 2 into 2. 4 minus 4 is 0. Now what is the third element of R4? Minus 1 minus 2 of minus 2. That is minus 1 plus 4. It is nothing but 3. Next, what is the last element of R4? It is 6 minus 2 into 3. 6 minus 6 is 0. Now we will replace all these 3 rows, that is R2, R3 and R4, with the new elements that are obtained. So the first row remains the same, that is 1 2 minus 2 3. Okay, so what are the elements that are obtained for R2? It is 0 1 0 0. For R3 it is 0 minus 1 0 1, and for R4 it is 0 0 3 0. So this is the matrix that is obtained after all these three operations. Now immediately I have to go for step 3. I have to make these three elements 0. For that I should make use of column 1. Okay, now let's see what are the operations here. See, if I multiply column 1 with 2 and subtract from column 2, then I can make this element 0. How will you write the operation? C2 implies C2 minus 2C1. You have to multiply column 1 by 2 and then subtract from column 2. In the same way, here it is a negative number, right? Here it is a negative number, so you have to perform addition. So C3 implies C3 plus 2C1. And the next one is C4 implies C4 minus 3C1. Okay, I will do it here, students. Check out here. First one is C2 implies C2 minus 2C1. Here this is R1, R2. For your reference I am writing here so that the confusion will be avoided. C1, C2, C3 and C4. Okay, so C2 implies C2 minus 2C1. So what is the first element of C2? It is 2 minus 2 into first element of C1 is 1. So 2 minus 2 is 0. Clear? Now what is the second element of C2? It is 1 minus 2 into second element of C1 is 0. So 1 minus 0 it is 1. Okay. Now what is the third element of C2? It is minus 1 minus 2 into 0. It is nothing but minus 1. In the same way, fourth element is 0 minus 2 into 0, 0. Now, coming to the next operation, what we have taken, C3 implies C3 plus 2C1. What is the first element of C3? Minus 2 plus 2 into 1. Minus 2 plus 2, it is 0. Next, what is the second element of C3? It is 0 plus 2 into 0. 0 plus 0 is 0. Okay. Now coming to third element of C3, it's again 0 plus 2 into third element of C1 is 0. So 0 plus 0 is 0. And what is the last one? The third element of C3 is 3 here plus 2 into 0. 3 plus 0 is 3. Now I'll perform the next operation here, students. Check out here once. C4 implies C4 minus 3C1. What is the first element of C4? It is 3 minus 3 into first element of C1 is, so 3 minus 3 is 0. What is the second element of C4? 0 minus 3 into 0. It's nothing but 0. Now, what is the third element of C4? 1 minus 3 into 0, which is again 1 minus 0 is 1. Now the last one is 0 minus 3 into 0, which is nothing but 0. So now we will replace C2, C3 and C4 now. The first column remains the same. So equivalent to, always use this symbol only. The first column remains the same, that is 1, 0, 0, 0. What are the new elements of column 2? It is 0, 1, minus 1, 0. For column 3 it is 0, 0, 0, 3. And column 4 it is 0, 0, 1, 0. Yes. Now what is step 4? After this are made 0, the step 4 is we have to come back to this element. which is already 1. So no need of any kind of operation. Now but below this we have to make these elements 0. This is already 0, so forget about it. Now we have to make this 0. How will you make it 0? C3 and C2. For that I have to make use of operation like R3 implies R3 plus R2. Okay, what is the first element of R3? 0 plus 0, which is nothing but 0. Okay, second element of R3 is minus 1 plus second element of R2 is 1, which is nothing but 0. Okay, and third element of R3 is 0 plus 0, that is nothing but 0. And what is the fourth element of R3? It is 1 plus R2, it is 0, which is nothing but 1. So now we will replace R3. First row remains the same, that is 1 0 0 0 0 1 0 0. R3, what are the new elements? 0 0 0 1 0 0 3 0. So this step has also been satisfied. I made these these two 0. Next I have to make these two 0, but they are already 0. Next we have to make this element 1, diagonal element, so they have to make this element 1, but it is 0 there, so I should swap with column 4. Okay, so C3 I am swapping with C4. Is that clear, students? According to the steps I explained you, that is for 3 by 3 matrix. This is a 4 by 4 matrix. So 4 by 4 matrix. So column 1 remains the same, that is 1 0 0 0. Column 2 is 0 1 0 0. Column 3 will be replaced with column 4, that is 0 0 1 0. And column 4 will be replaced with column 3, that is 0 0 0 3. Now the last step is I have to divide R4 by 3 so that the last row will become 0. Okay, so this is the last operation. So 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0. 3 by 3 is 1. Sorry. Three by 3 is 1. If you observe carefully, this is a 4 by 4 identity matrix. 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. It is a 4 by 4 identity matrix, or you can also count the number of non-zero rows. This is a non-zero row, non-zero row, non-zero row and non-zero row. So therefore the rank of the matrix is 4. Is that clear, students? Therefore rank is equal to 4. Hope you understood, students. Next, find the rank of the following matrix using normal form. This has been asked in 2010. Now first let me write the matrix once again. Okay. A is equal to 1 2 1 2 1 3 2 2 2 4 3 4 3 7 5 6. Okay, Yeah, what is the first step? The first step is I should make 1, but it is already 1, so no need of any operation. The next step is I should make these 3 elements 0. For that I should make use of first row. So let's see what are the operations here. R, if I multiply, see, okay students. See, R2 implies R2 minus R1. Okay, 1 minus 1, 0. Now if I multiply R1 with 2 and subtract from R3, then it can be made 0. If I multiply R1 with 3 and subtract from 3, then this element can be made 0. Okay, we will write the operations here. So R3 implies R3 minus 2R1, and the next one is R4 implies R4 minus 3R1. Okay, let me do here students. The first one is R2 implies R2 minus R1. What is the first element of R2? It is 1, minus 1, 0. Okay, second element of R2 is 3 minus 2, which is nothing but 1. Third element of R2 is 2 minus 1, 1. And here it is 2 minus 2, 0. Now coming to the second operation, that is R3 implies R3 minus 2R1. What is the first element of R3? 2 minus 2 into first element of R1 is 1. So 2 minus 2 is 0. What is the second element of R3? 4 minus 2 into 2, which is nothing but 4 minus 0, 0. Next, what is the third element of R3? 3 minus 2 into 1. 3 minus 2 is 1. And what is the fourth element of R3? 4 minus 2 into 2, which is nothing but 0. Now what is the third operation? R4 implies R4 minus 3R1. What is the first element of R4? 3 minus 3 into first element of R1 is 1. So 3 minus 3 is 0. Okay. Now what is the second element of R4? 7 minus 3 into 2. 7 minus 6 is 1. Next, third element of R4 is 5 minus 3 into R1 is 1. 5 minus 3 is 2. Now, what is the last element of R4? It is 6 minus 3 into 2. 6 minus 6 is 0. Now, let us replace this here. So, this implies the first row remains the same, that is 1, 2, 1, 2. What are the new elements of R2? It is 0, 1, 1, 0. What are the new elements of R3? It is 0, 0, 1, 0. And what are the new elements of R4? It is 0, 1, 2, 0. Fine. Done. Next, go for step 3. What is step 3? I have to make these elements 0. For that, I have to make use of column 1. So if I multiply column 1 with 2 and subtract from column 2, then I can make this element 0. And the next operation will be C3 minus C1 directly. 1 minus 1, 0. Again I have to multiply column 1 with 2 and subtract from column 4. Then this element can be made 0. Okay, we will write down the operations here students. C2 implies C2 minus 2C1. Okay, C3 implies C3 minus C1 simply. And C4 implies C4 minus 2C1. Okay, let's see here the calculation part here. So what is the first one? It is C2 implies C2 minus 2C1. What is the first element of C2? So this is R1, R2, R3, R4. This is C1, C2, C3 and C4. So now tell me what is the first element of C2? It is 2 minus 2 into first element of C1 is 1. So 2 minus 2 is 0. Okay. Now what is the second element of C2? It is 1 minus 2 into 0. It's nothing but 1. Next, third element of C2 is 0 minus 2 into C1 is 0. So it is nothing but 0. And fourth element of C2 is 1 minus 2 into fourth element of C1 is 0. So 1 minus 0 is 1. Now, what is the next operation I have taken? C3 implies C3 minus C1. So what is the first element of C3? It is 1 minus 1, 0. Okay. 1 minus 0, it is 1. 1 minus 0, 1. And 2 minus 0, it is 2. Yes. Is that clear, students? Now the last operation, see here. C4 implies C4 minus 2C1. What is first element of C4? 2 minus 2 into C1 is 1. So 2 minus 2, 0. Okay. What is the second element of C4? 0 minus 2 into 0 is again 0. Third element of C4 is 0 minus 2 into 0. Alright, it is again 0 here. And the last element of C4 is 0 minus 2 into 0. So column 4 is completely made 0 here. So we will now replace these values and we write on the matrix here. The first column remains the same. That is 1, 0, 0, 0. What is the second column? New elements we got 0, 1, 0, 1. And the third column new elements are 0, 1, 1, 2. And the last column is a 0 column. Okay. Hope it is clear to you, students. Next, what is the next step? I should come back to the second diagonal element, which is already 1. So there is no need to perform any operations. Next is we have to make these two elements 0. This is already 0. So no need to perform any operations. Here I should make 0. For that, R4 minus R2. That is 1 minus 1, 0. So that operation we are going to perform here. R4 implies R4 minus R2. Okay. So first is 0 minus 0. It is 0. 1 minus 1. It is 0. What is the third element of R4? 2 minus 1. It is 1. Okay. And the last element of R4 is 0 minus 0. It is 0. So I will write down here, students. This implies the first 3 rows remains the same. That is 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0. And what are the new elements of 4th row? 0, 0, 1. Sorry. 0, 0, 1, 0. Yes. Now, so I made this 0. Okay. So I should go back to this. I should make this to 0. This is already 0. So I should make this one 0. For that, what I have to do? C3 minus C3 minus C2. That is 1 minus 1, 0. Okay, I will write down what are C3 and C2 for here. This is R1, R2, R3 and R4, C1, C2, C3 and C4. Okay, so C3 implies C3 minus C2. That is, what is the first element of C3? 0 minus first element of C2, 0, which is nothing but 0. What is the second element of C3? It is 1 minus 1, which is nothing but 0. What is the third element of C3? It is 1 minus 0, 1. Okay. And fourth element of C3 is 1 minus 0. One minus 0, 1. Okay, now I will replace this C3 here. The remaining columns will be the same. Okay, this implies the remaining columns remains the same. So first write down the columns 1 0 0 0 0 1 0 0. What are the new elements of C3? It is 0 0 1 1 and the last column are zeros. Is that clear, students? Now I made this 0. After this I should come back to the third diagonal element, that is 1. It is already 1. So now I should make this element 0. Below the diagonal element I should make this element 0. For that, simply what you have to do, I have to perform R4 minus R3. R4 minus R3. So what is the first element of R4? 0 minus 0, which is nothing but 0. Second element of R4 is 0 minus 0, 0. Third element of R4 is 1 minus third element of R3 is 1, again 0. Okay, last elements are 0. Now I will replace this fourth row. Now the remaining rows will be the same. Okay, 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 0. That's it, students. Clear? Now all the steps have been completed. Now check for the rank. Now see, it is 1 0 0 0 1 0 0 0 1. It is clearly a 3 by 3 identity matrix. So how can you write this? It is I3 0 0 0. What is the suffix here? It is 3. So therefore rank of the matrix is equal to 3. Or else you can check for non-zero rows. How many non-zero rows are there? 1, 2 and 3. Therefore rank is equal to 3. Is it clear, students? All the 3 problems. First you have to know the steps for 3 by 3 matrix or 4 by 4 matrix, and you have to perform row operation or column operation accordingly. Hope you understood, students. For more videos and problems, please do subscribe Sankalp Study Success channel and download the app. In the app, we have lot of solved problems and assignment problems too. Try those assignment problems after watching my videos. Understand the concept and then try to solve those assignment problems. Thank you.